This lesson is on the zero product property. The idea of this property is that when you take 0 and you multiply it times anything, that's going to have a product of 0. In other words, two factors where one factor is a 0, that means that when you multiply it, it will equal 0. This is important because then when we're dealing with equations such as this, you have to think of this as two separate factors. This number times this number equals 0. So if we can make one of these numbers or one of these factors equal to 0, then that means this entire expression would then equal 0 because 0 times anything will equal 0. Likewise, 0 times anything will equal 0. So when you see a problem like this, we want to figure out what values x can be so that when you plug it into here, it makes one of these factors equivalent to the number 0. So we take this and we break it into two separate equations. To find out what that x is, we're going to do the inverse operations. So the opposite of subtracting 3 means we would add 3 to both sides, and so x would equal 0 plus 3, which is 3. And then we do the same with this expression over here, 2x plus 5. Now we're going to set it equal to 0. So we would subtract 5 from both sides so that these would cancel. So 2x would then equal 0 minus 5, which is negative 5. Then the opposite of multiplying by 2 would be to divide by 2 so that these would cancel and x would equal negative 5 halves. So if x equals either 3 or negative 5 halves, it makes the entire equation here equal to 0. Let's just check it out with 3, for example. If we put a 3 in here, 3 minus 3 is 0. 0 times whatever this is still going to equal 0. So these would be the two solutions to this problem. Sometimes you have a problem that looks like this where the factors aren't as easy to identify, so you would want to go ahead and factor it. So if you want, you can make a factor x. So we think negative 18 here, a number that would multiply together to give us negative 18, and then those two numbers would add together to give us negative 3. So I think of 6 times 3, but this one would have to be negative because negative 6 times 3 is negative 18. Negative 6 plus 3 equals negative 3. So when we would factor this, we'd say we have x minus 6 times x plus 3, and that would equal 0. And so then what would we do? Well, we just got to get one of these factors to equal 0. So we break this off and we find out what are those values that x can be so that the whole expression or the equation would equal 0. So in this one, if we add 6 to both sides, x equals 0 plus 6, which is 6. This one, if we subtract 3 from both sides, x equals 0 minus 3, which is negative 3. So if x equals 6 or x equals negative 3, at either one of those two values, the whole equation would then equal 0. In this particular problem, I see I have 4 terms on this side, so I'm going to factor by grouping. So I have x cubed plus x squared, and then we would have plus x plus 1, and that would equal 0. Give me a second. So from here, the GCF out of this would be x squared, and then we have x squared times x plus 1 would give me x cubed plus x squared. And then this one, the GCF here is 1. So inside we'd have x plus 1 equals 0. So on the outside we have x squared plus 1 times x plus 1 equals 0. So now we can break this off into two separate equations here. There's the first one. Here's the second one. So if I subtract 1 from both sides, x squared is going to equal negative 1. And then the inverse of squaring is square rooting. So we'll take the square root of both sides. Remember, when we take the square root, we take the positive and negative of the square root. So x would equal positive and negative. Now, here's the thing. Square root of 1 is 1, but then we have this negative here, so that would be an I if we take the square root of negative 1. So this is like negative 1i, or x equals plus or minus I. And then this one here, if I subtract 1 from both sides, we have x equals 0 minus 1, which is negative 1. So we're looking at some solutions here of x equals negative 1, positive I, and negative I.